In this video, we are going to see about degree of freedom. This topic is very important thing. So while you're discussing about mechanism, so we know what is mechanism and consists of link and pair, lot of things. So even though it is not more than enough to learn, so we have to go beyond that. What is degree of freedom? So the degree of freedom, what it tells about in mechanism is, it tells about that how much amount of input that has been needed to run in such a mechanism. So it can be given in different ways. So likely we can say that how many number of an independent relative motion in a pair, or you can call this in a kinematic pair, or else we can able to define in this minimum number of an input parameters that is needed to specify the location of every link within the mechanism, or sometimes we can call it as a number of input parameters. Usually we can call their name pair variables. So I will make it clear for you. Just think about this two different mechanism I have drawn here. So one is called single stator mechanism and another one is called four bar mechanism. In this, we know that how much input is needed, that it describes about that degree of freedom. Here I am using one variable that can called as an pair variable, that is the theta. The theta is the only term which is used to define the location of all the links in this mechanism. Likewise, if you look onto that four bar mechanism, in this also we are using that only one variable, that is theta. It is used to define all the location of every link in this mechanism. Okay, I will make it to clear what is exactly degree of freedom. So let me move on to this diagram. So you know very well, if you place your object in a space, how much degree of freedom it possesses. Here I clearly explained you, it have the possibility to move in x direction, maybe 2 and 4. Likewise, we have that particular object can able to move in y direction also, x and y. Similarly, it can have the possibility to move in z direction. So totally we can have 3 axis translational. Similarly, if you look on to the rotational about x, y and z. So totally we can have 6 degree of freedom for a space mechanism. If you look on for a plane, suppose I'm going to construct a mechanism in a plane, how much degree of freedom it possesses. So here, just for an example, I can take this duster to make it clear for you. So let's take this board as a plane. So I'm having the object in this plane. So how many degree of freedom this particular object possesses? It have the possibility to move in x direction. Similarly, this particular object, it have the possibility to move in y direction also. So now I have 2 degree of freedom and one more degree of freedom it possesses. This particular object, it have the possibility to rotate about this z axis. So totally if you count means we having a 3 degree of freedom for a plane. I hope you understand what is degree of freedom. In next video, we can see the space. In this video, we're going to discuss about the expression for degree of freedom. So we already discussed about the different classification of mechanism. So likely spatial, planar and spherical. Now we're going to discuss about the degree of freedom expression for spatial mechanism. You know very well, in order to operate a mechanism, any one of the link has to be fixed. In this way, if you have to look out for number of movable links in a mechanism, it is given as n minus 1. So let it take a few of that assumption here. Let take that n will be the number of link in a mechanism and f be a degree of freedom and p1 will be number of one pair which having a single degree of freedom. Likewise, p2 will be the number of one pair which having 2 degree of freedom. It will be keep on going, right? Now let you move on to the number of one movable link. As earlier I told that if you take any mechanism, any one of the link has to be fixed. Then only we can call it as an mechanism or linkage. So in this basis, the common expression which is given for number of movable links will be equivalent to n minus 1. I'm going to apply for an space mechanism. So you know very well, any object it is placed in space, it possesses 6 degree of freedom. Now I'm going to count for number of degree of freedom for movable link in a space mechanism. So I'm going to multiply with 6 into n minus 1. Okay, all right. Now I'm going to find how many number of one pair which having single degree of freedom. So let for example, if we take number of one pair which having single degree of freedom means out of 6 degree of freedom, only one pair having 1 degree of freedom means remaining 5 you should be your restraints is there. So it will be reducing the degree of freedom reducing by 5p1. Similarly, let me take number of pair which having 2 degree of freedom means it will be reduced by 4p2. Likewise, 3 degree of freedom be 3p3 and 4 degree of freedom will be 2p4 and 5 degree of freedom will be p5. Finally, I'm going to conclude this one. You should know very well, we are going to find how many number of degree of freedom that particular mechanism possesses. So this should be added or subtracted. So this should be neglected. So in this way, I just arrange the expression like this: f equal to 6n minus 1 minus 5p1 minus 4p2 minus 3p3 minus 2p4 minus p5. This is a final expression which you can able to use only for space mechanism alone. So in most of the mechanism for a design purpose and analysis purpose, we can go with an planar mechanism. So now we can see that how the expression given for degree of freedom for planar mechanism. In previous video itself, I told that for a planar, we having a 3 degree of freedom we possess. So based upon that only, I'm using the value 3 here. In space, we having 6 because it possesses 6 degree of freedom. In planar, we having 3, so I'm using that numerical value 3 here. And 3n minus 1 minus 2p1 minus p2. Here, the p1 will be the number of unpair which having single degree of freedom and p2 will be number of unpair which having 2 degree of freedom. This particular expression, it is called as an Krubler's criteria. When this particular expression is limited to have single degree of freedom means we can able to write in this way: f equal to 3n minus 1 minus 2p1. This expression is called as an Pushback criteria. In lot of that authors, they have been referred interchangeably. They can call this as an Pushback and this as an Krubler's. You can use interchangeably this criteria. And commonly, in order to find degree of freedom for a planar mechanism, you have to refer this expression: f equal to 3n minus 1 minus 2p1 minus p2. In this video, so we're going to see a few mechanisms how to find degree of freedom. So all the mechanism here I showcased is a planar mechanism. So let me see that how we're going to find degree of freedom for such mechanism. So just you can remember that you should know that expression which has been discussed in the previous video, that is f equal to 3n minus 1 minus 2p1 minus p2, where n stands for number of links and p1 stands for number of unpair which having single degree of freedom. Likewise, the p2 stands for number of unpair which having double degree of freedom. Right, let me move on to this case. Just look at this mechanism. Here we going to collect how many number of links in this mechanism, as well as we're going to collect how many number of unpair it possesses. Okay, let me start the count. Let me start from this way. So all the fixed link, this is very important here. In many mechanism, there are so much of fixed link. It should be counted as an 1. So because it doesn't have no velocity, the displacement will be 0. So because of the reason, it should be counted as a single link. So when they are having relative motion means you can account as a link. But only one thing, the fixed link should be counted as a single link. Right. So here all the fixed link I counted as an 1. And this is link 2, and this is link 3, and this is link 4, and link 5, link 7, and link 6, link 7, and the slider will be the link 8. And here we having the combination of an turning pair and as well as sliding pair. So the link 2, 3, 4, 5, 7, 6, which will constitute your turning pair, and the link 8 and 8, 3, 4, so which will have your sliding pair. So now we're going to focus on how many pairs which having a single degree of freedom. So let me start in this way. So 1 and 2 makes one pair, and 2 and 3 makes another pair, and 3 and 4 makes one more pair, and 4 and 5 makes one more pair, and 1 and 7 it makes one pair, and 7 and 5 makes one pair, and 5 and 6 it makes one pair, and 6 and 1 makes one pair. Here we having this the slider and that link joining of 3 and 4 it makes one pair, and the slider which is fixed on that fixed link it makes one more pair. So totally I count all the pairs 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So totally we can arrive at 10 pair in this mechanism. So now we're going to use this expression to find degree of freedom here. So number of links we having 8 and number of unpair which having a single degree of freedom is 10 and you're looking for an P2. So you know what is meant by P2? The number of unpair which having 2 degree of freedom. So all the turning pair which having possess only single degree of freedom, and you also we having a sliding pair. Sliding pair also possess single degree of freedom. So in this mechanism there is no possibility of unpair which having 2 degree of freedom. Because of that I use as 0 here. So if substitute here means you will get 1 degree of freedom. So what is exactly meaning of 1? The one it gives us this particular mechanism, it needs one input to run this mechanism. That is the meaning of f equal to 1. Suppose in some cases where you're dealing with another cases means suppose f equal to 0. So what does mean that is the motion is impossible. So we can call it that particular arrangement is called structure. Suppose in some cases, so we having -1. So what is the meaning of this one? That particular structure you can call it as a superstructure, and we couldn't able to find statically indeterminate structure. So it is not possible here. And in this particular arrangement, the chains is called as a redundant chain. So these are the few informations which are added here, right? Now we could move on to the next problem. Here also we having more number of links, and I think this on this mechanisms we only having a turning pair. So I mean, there is no probability for P2, that is number of n pair which having 2 degree of freedom. So let me check how many links in this mechanism. So 1, 2, 3, 4, and 5. The 5 is a ternary link. I think you should be able to identify that type of link is ternary. And 6, 7, 8, 9, 10. All the fixed link I consider as a single link and I label it as a 10 year. Okay. Now I'm going to find how many number of unpair in this mechanism. So 1 and 10 makes one pair, and 2 and 1 makes another pair, and 2 and 8 makes one more pair, and 8 and 3 makes one more pair, and 4 and 3 makes one more pair, and here 5 and 4 makes one more pair, and 5 and 6 makes one more pair, 6 and 7 makes one more pair, 7 and 10 makes one more pair, and 9 and 5 it makes one more pair, and 9 and 10 makes one more pair, 8 and again the 9 it makes one more pair, and this again 8 which is connected to this join it makes one more pair. So totally we can have that number of unpair should be 12 and number of links we having is 10 here. And some people you might have some difficulty to finding the number of unpair manually. So I think the type of a join here we having here is ternary join. So we already discussed that one ternary join will be equivalent to two binary join. For all binary join we having one pair. So here we having two binary join means it will be equivalent to two pair. That's it, very simple. Suppose if we having the quaternary join means it will be equivalent to three binary join. So we can say that three pair will be available in these cases. So I think finally we can arrive that value after substituting this value means we getting 3. So what is the meaning of this 3 is this mechanism which needs 3 individual input to run this mechanism. So thank you.